What if I told you that the same force that powers the sun also powers our cities? That the energy inside a tiny atom can light up entire nations? Welcome to the science behind. Today, we're diving deep into the mind-blowing world of nuclear energy, the power source that could shape our future. Let's break it down. How does nuclear energy work, and why is it one of the most powerful energy sources on Earth? Everything around you is made of atoms, tiny building blocks of matter. But inside each atom is an immense force waiting to be unleashed. This process is called nuclear fission, the key to unlocking nuclear power. In simple terms, when we split an atom, usually uranium-235, it releases a chain reaction of energy. That energy is then converted into electricity, powering millions of homes. So how does a nuclear power plant turn this atomic energy into electricity? First, uranium fuel rods are placed inside a reactor, where neutrons are fired to start the chain reaction. This reaction produces heat, which boils water and turns it into high-pressure steam. The steam spins massive turbines which generate electricity, just like in a coal or hydropower plant. Finally, the steam cools down, and the process repeats, producing clean carbon-free energy. Now, how does nuclear power compare to other energy sources? Unlike coal, nuclear energy produces zero carbon emissions, making it a clean energy source. Unlike solar and wind, which depend on the weather, nuclear power provides consistent energy 24/7. And unlike hydropower, which requires large dams and rivers, nuclear plants need far less land to generate the same amount of energy. With rising energy demands, nuclear energy could be the key to a cleaner, more sustainable future. But nuclear energy isn't without risks. History has seen disasters like Chernobyl and Fukushima, raising concerns about safety and radioactive waste. However, new safety technologies, next-gen reactors, and even nuclear fusion could eliminate these risks, making nuclear power safer than ever. So, what do you think? Is nuclear power the future of energy, or do the risks outweigh the benefits? Comment below and share your thoughts. If you love learning about how the world works, make sure to like, share, and subscribe for more mind-blowing content. Let's explore the history of nuclear energy. How did we discover the power of the atom? The journey began in the early 20th century with scientists like Ernest Rutherford and Niels Bohr, who uncovered the mysteries of atomic structure. Their groundbreaking work laid the foundation for our understanding of nuclear physics. The first controlled nuclear chain reaction was achieved by Enrico Fermi in 1942, marking the dawn of the nuclear age. This monumental breakthrough took place in a makeshift lab under the stands of Stagg Field at the University of Chicago. It was here that humanity first harnessed the immense power locked within the atom. This breakthrough led to the development of nuclear reactors and the first nuclear power plants in the 1950s. The world's first commercial nuclear power station, Calder Hall in the UK, began operating in 1956, signaling a new era of energy production. Today, nuclear energy is a vital part of the global energy mix, providing about 10% of the world's electricity. From powering homes to fueling space missions, nuclear energy has come a long way since its early days. As we continue to innovate and improve safety measures, the potential for nuclear energy to drive a cleaner, more sustainable future grows ever brighter. Want to know more about the pioneers of nuclear energy and their incredible discoveries? Stay tuned as we delve deeper into the fascinating stories behind the science. Now, let's dive into the different types of nuclear reactors. The most common type is the pressurized water reactor, or PWR. This reactor uses water as both a coolant and a moderator, keeping the reactor core at high pressure to prevent the water from boiling. This design is known for its stability and is widely used around the world. Next, we have the boiling water reactor, or BWR. In this type, water boils inside the reactor vessel to produce steam directly. This steam then drives the turbines to generate electricity. The simplicity of the BWR design makes it an efficient and cost-effective option. Moving on to more advanced reactors, we encounter the fast breeder reactor, or FBR. Unlike traditional reactors, FBRs use fast neutrons to convert non-fissile materials into fissile ones, effectively breeding fuel. This allows for a more efficient use of nuclear fuel and has the potential to significantly extend our fuel supply. Another innovative design is the molten salt reactor, or MSR. Instead of using solid fuel rods, MSRs use liquid fuel mixed with molten salt. This unique approach offers enhanced safety features and the ability to operate at higher temperatures, leading to greater efficiency. Each reactor type has its own advantages and challenges, contributing to the diversity of nuclear technology. Whether it's the widespread use of PWRs and BWRs, or the promising future of advanced reactors like FBRs and MSRs, the evolution of reactor technology continues to drive the progress of nuclear energy. Stay tuned as we explore the future innovations that could revolutionize how we harness nuclear power for a cleaner, more sustainable world. Safety is a paramount concern in nuclear energy. Modern reactors are designed with multiple safety systems to prevent accidents. For instance, the containment structure is a robust barrier that prevents the release of radioactive materials. Emergency cooling systems can quickly shut down the reactor in case of a malfunction. Additionally, passive safety features, which rely on natural forces like gravity and convection, enhance the reliability of these systems. Continuous research and development are focused on making nuclear power even safer. But how do these safety measures work in real-time scenarios? Imagine a sudden power failure. In a traditional system, this could spell disaster. However, modern reactors are equipped with passive safety systems that automatically activate without the need for human intervention or external power. Gravity-driven cooling systems, for example, ensure that coolant flows to the reactor core, preventing overheating. Furthermore, the industry adheres to stringent regulatory standards. Regular inspections, rigorous training programs, and state-of-the-art technology ensure that nuclear plants operate safely and efficiently. International collaborations like those led by the International Atomic Energy Agency, IAEA, set global safety benchmarks and facilitate the sharing of best practices. The commitment to safety extends beyond the reactors themselves. From the transportation of nuclear materials to the long-term storage of nuclear waste, every step is meticulously planned and monitored. Advanced technologies such as dry cask storage and deep geological repositories provide secure solutions for managing nuclear waste. As we continue to innovate and improve, the future of nuclear energy looks brighter and safer than ever. By prioritizing safety, we can harness the immense power of the atom to fuel our world sustainably and responsibly. Join us next time as we explore the groundbreaking advancements that promise to make nuclear energy even more secure and efficient. Let's address the issue of nuclear waste. Spent nuclear fuel is highly radioactive and must be carefully managed. Currently, it is stored in secure facilities, either in pools of water or in dry casks. These methods ensure that the radioactive materials are contained and shielded from the environment. But what about long-term solutions? Deep geological repositories offer a promising answer. These facilities are designed to isolate nuclear waste deep underground, where it can remain secure for thousands of years. This approach minimizes the risk of contamination and provides a stable environment for the waste. Scientists are not stopping there. They are also exploring advanced recycling technologies to reduce the volume and toxicity of nuclear waste. By reprocessing spent fuel, we can extract valuable materials like plutonium and uranium, which can be reused in reactors. This not only reduces the amount of waste but also maximizes the use of our resources. These innovations are crucial for the sustainable future of nuclear energy. By addressing the challenges of nuclear waste, we can ensure that this powerful energy source remains a viable and responsible option for generations to come. Stay tuned as we continue to explore the fascinating world of nuclear energy and the advancements that are shaping its future. Nuclear fusion is often hailed as the holy grail of energy. Unlike fission, which splits atoms, fusion combines them to release energy. This process powers the sun and promises virtually limitless, clean energy. However, achieving controlled fusion on Earth is extremely challenging. Projects like ITER in France are working towards making fusion a reality. If successful, fusion could revolutionize the energy landscape, providing a safe and abundant source of power for future generations. But why is fusion so elusive? The conditions required for fusion are extreme, temperatures of millions of degrees and immense pressure. Creating these conditions in a controlled environment on Earth is no small feat, yet the potential rewards make it worth the effort. Fusion produces minimal radioactive waste and uses fuel sources that are abundant and widely available, such as deuterium from seawater. Imagine a world where energy is not a limiting factor, where clean, sustainable power is available to everyone, everywhere. This is the promise of fusion energy, a promise that fuels the dreams and efforts of scientists and engineers around the globe. We are on the brink of a new era in energy. With continued innovation and determination, the dream of harnessing the power of the stars could soon become a reality. The journey is long and fraught with challenges, but the potential benefits are too great to ignore. Join us as we look forward to a future powered by the limitless energy of nuclear fusion. Public perception and policy play crucial roles in the future of nuclear energy. While some people are wary of nuclear power due to past accidents, others see it as a necessary solution to combat climate change. Governments around the world are investing in nuclear research and development, with countries like China and Russia leading the way in new reactor construction. International cooperation and transparent communication are essential to build public trust and support for nuclear energy. By addressing safety concerns and demonstrating the benefits of nuclear power, we can pave the way for a sustainable and secure energy future. It's not just about technology, it's about people, policies, and the collective will to harness nuclear energy responsibly. As we move forward, let's remember that the power of the atom can be a force for good, providing clean, reliable energy for generations to come. Finally, let's look at the future of nuclear energy. Innovations like small modular reactors or SMRs and Generation 4 reactors promise to make nuclear power more flexible, efficient, and safe. SMRs are compact and can be deployed in remote locations or integrated with renewable energy sources. This versatility could revolutionize how we think about and use nuclear energy, bringing power to places that were previously unreachable. Generation 4 reactors, still in development, aim to use fuel more efficiently and produce less waste. These advancements could address some of the major concerns surrounding nuclear energy, making it not only a reliable source of power but also a more sustainable one. Imagine a world where nuclear energy is a cornerstone of a resilient energy system, working in harmony with renewables to combat climate change. As these technologies evolve, they hold the potential to transform our energy landscape, providing clean and reliable power for future generations. The journey ahead is filled with challenges but also immense possibilities. The future of nuclear energy is bright, and it's up to us to harness its full potential responsibly and effectively. Thank you for joining us on this exploration of nuclear energy. Until next time, let's keep pushing the boundaries of what's possible and strive for a sustainable, energy-rich future.